Hi, today I'm going to describe how to measure the heartbeat from the heartbeat sensor. I have already implemented all the hardware on the breadboard and on PCBs by soldering the devices. First of all, I would like to describe you on the circuit which I exactly implemented on the hardware. So my this heartbeat sensors gives without signal when I powered it on, without signal, like when I don't touch it, then it gives the signal output voltage around 2.06 volt or something like that. So I need to amplify it to measure it, right? So for that I need amplifier, but with the whose reference I'm gonna to amplify, right? So for that one I am going to use potentiometer. So this circuit is the potentiometer, and it will give, I will give 5 volt to potentiometer. After that I need heartbeat sensor. It also needs 3 to 5 volt. So both of them I'm going to give to LM358 IC, which is nothing but the operational amplifier, and in this case I'm going to use it as a differential amplifier. So the heartbeat sensor I'm going to give on the pin number 3 on the non-inverting input, and the potentiometer I also set the potentiometer value as 2.04 volt around. So it's like a to balance the both input. When I will touch to the sensor, it will give some difference, right? High or plus or minus. So according to that, whatever the difference this op-amp will give, it will amplify it. And after amplify it, this 10k is the feedback resistor. And I forgot to write it. It's the 1k. This is the 1k resistor, and by this is the optocoupler to get the proper exactly 0 or a 1 volt. So here I have used MC to 2E optocoupler. Whenever there will be high output, inside there will be this is the combination of LED and a phototransistor. When LED is on, then this 3.7 this will be work in, this will go in active region, and this will give simply 3.7 watt to the output. So in this case I have used the LED to for our to understand that for the beat is we are getting the beat or not. So now the same thing I'm going to show you on the breadboard, and there was some loose connection on the breadboard, so I made some hard soldering on the PCB. So as in the circuit, potentiometer, LM358, and optocoupler, and our heartbeat sensor, same thing. This is the potentiometer, this is LM358, and this is the optocoupler. But when I was soldering, there was some problem, and it failed. So fortunately I already had ordered the second one, so I'm using this optocoupler to here. And this is the heartbeat sensor, right? So now I'm going to show first the connection of the hardware. So as exactly showing here, I use 500 ohm as well. Yes. I'm going to give a non-inverting input the heartbeat sensor signal with the 500 ohm resistor. So you can see it was just moving here and there, that's why I fixed it. So this is first of all, when I turn on the battery, see here, potentiometer needs 5 volt, signal also needs 3 to 5 volt, and optocoupler and LM358, this both need around 3.7. This also works on the 3 to 5 volt. So my battery is giving me 4 volt, so I gave them like this voltage. So from my battery I use the LM358 IC, which gives me 5 volt, and I took the 5 volt here in this way. And my battery also gives me 3.7 volt. So because my battery is 7.6 volt, this is giving me at this area I got the 3.7 volt. So for my heartbeat sensor I got some very fluctuated voltage, so I did not give it a 5 volt, but yes, I gave it 3.7 volt. So from this section I give 3.7 volt to my heart rate sensor. This is plus, minus, and the signal, the green one is for the signal. So that signal you can see here, I don't have 500 ohm resistor, so that's why I took two 1 kilo ohm resistor and made it parallel and made it 500 ohm, and then after through the resistor I give to the input here to the LM358's non-inverting input at the pin number 3. You can see here, right? This is the pin number 3 and this one. Now the second input to the op-amp is the potentiometer. So as per the circuit, uh, I did one resistor ground, and from the top of that resistor using 500 ohm again I give it to the non-inverting input, inverting input. So again I give this one, yeah, this potentiometer. I give 5 volt to potentiometer. You can see here, this is the 5 volt panel. So from this I give 5 volt, you can see this, and I solder it on the down. So it's a 5 volt here, as on this, as I saw in the circuit. I first pin and second pin I sort it and give to the first 5 volt to it, and the third pin I give to the ground using resistor, and one of the from this way I took the output using the 500 ohm again to 1 kilo ohm resistor on the parallel. I took 500 ohm, and again I give it to the inverting input here to the LM358 pin number 2, right? Okay. Now as here I see pin number 1 and 2, I give the feedback by using the 10k resistor. So it's a little bit hard to show exactly here, but yes, I did the same thing by this way. There is a, see, this is the feedback resistor. I give you to pin number 1 and 3, 1 and 2 to the LM358, and the output of LM358 is on the pin number 1 here, that is given to the MC22E. So here the MC22E, but this optocoupler is failed, so fortunately I had ordered the another one, so I'm going to use that one. So here you can see from the pin number 1 of LM358 I gave here, and through the resistor as I shown in the circuit diagram, through the resistor I'm going to give it to the pin number 1 of optocoupler, and optocoupler's second pin is the ground. You can see here, right? Yeah, this is the input to the first pin, and this is the ground, and 3.7 volt on the pin VCC pin is 3 number, so I gave it on the pin number 2 the 3.7 volt from here, as you can see, and from pin number 3 I'm getting, as I shown in the circuit diagram, from the pin number 3 sorry, 1 2, here is the 3 4 5 and 6. So 4 5 number is I'm giving power supply, and from this pin I'm getting the output, and the LED is connected for our to see. So here from this pin number 1 2 3 4 I'm getting the output, and through one resistor is ground, and through one LED is also ground. So now how it works, I'm going to give power supply and then we will see. Yes, so you can see I give the power supply here from the battery, so it's on. Due to the some noise, this LED is blinking, and here is the heart rate sensor. I will gonna to fix this problem using the capacitor, like using a filter, but for now I'm just showing you. So now I'm going to place my finger on the heartbeat sensor. I just put the finger. Now you can see it takes some time to recognize the heartbeat. So now it's start. So that's it. Thank you to watch my video.